Hello everyone. So today we start a new chapter. It's called Tuples in Python. This is for class 11. Now before I get you into this chapter called Tuples, I would want to discuss something we have learned in chapter 2 called data handling in Python. In data handling in Python, we had learned there is a category of data type called the sequence data type. And within the sequence data type, we had said the three types of data types under sequence data types are strings, lists, and tuples. We've already learned string and list. So today we'll be learning the chapter called tuples. But it will be much faster here because it is quite similar to the way list and tuples work, or the operations that you've performed on list and tuples can also be performed, with list and strings can also be performed on tuples. But there is a difference also. I will tell you as we move ahead. So what are we planning to learn in this video? So in this video, we will be learning what exactly is a tuple, how do you get values from the user and store it into a tuple. Then we'll be comparing it with lists and strings. Then we are going to be learning something new called packing and unpacking tuples. And finally, all the methods and functions that we use with tuples. So are we ready to start? Okay, now coming to the introduction. Now what is a tuple? Tuple is nothing but a sequence of elements that are separated from each other using a comma and written within parentheses. Parentheses means round bracket. Now these sequence of elements that you plan to write can be of the same data type or different. The same thing we saw in list as well, and I said it's a collection of heterogeneous or homogeneous elements. When I say homogeneous, all the elements are of the same kind. Heterogeneous means all the elements of the tuple could be of different data type. Clear? And I said it's depicted using or implemented using the round brackets, which is also called parentheses, whereas a list was implemented using a square bracket. Another important thing that you need to know about a tuple is immutable. That means once you have created a tuple, you cannot go to that memory location and update the existing tuple that you could do like you could do in a list. Strings were also immutable. So the two sequence data types that are immutable, one is a string, the other is a tuple. Okay. Now, how do we write a tuple in our programs? The first one shows you an example of a tuple called tup1, which consists of 4 elements. One is an integer, one is a floating point value, and you have 2 strings. So this is a heterogeneous sequence of elements. Tup2 is homogeneous because all are integers. Tup3 is also homogeneous because all are treated as strings. But you need to understand here is I did not put the parenthesis. So parenthesis is not compulsory. Even if you write elements separated by a comma, it's going to be treated as a tuple. Okay. Next is, how do you create an empty tuple? An empty tuple is created with just empty parentheses. Now, what if you have only one element in the tuple? Then what do? You still write the element and you put a comma after it. Can you see on that line which says tup1 is equal to in bracket 50 comma? Even if there are no more elements, you need to put a comma. Now, why do you need to put a comma? If you wouldn't have put the comma, then tup1 would have the value 50 and tup1 would not be of type tuple, but instead it would be an integer. So even if you have one element in the tuple and you want it to be treated as a tuple, then remember to put the comma. Is that clear? Okay. Now, how do you accept values from the user? Now, there are 2 ways that we could accept value from the user when we used a list. One was using the list method, one was using the eval method. Here too, we are going to be using one method called the tuple method, one method called the eval method. But both ways, whatever we learned in list is applicable here also. So the first method I'm saying is using a method called tuple with your input function. But in this scenario, just remember, all the elements that you enter, whether your elements are numbers or digits or hash, dash, special characters or alphabets, each of those characters are going to be treated as one element of a tuple. So here the number was entered as 1224, but 1 is treated as one element of the tuple, then 2 is treated again and as another element of tuple, 2 again as a third element of tuple, and so on. It's not necessarily, it could be digits. They're all going to be treated as a string. Can you see the quotes in the answer? And all of these elements are enclosed within parentheses, so that makes it a tuple. So this is one way. Another way is making use of the eval function. But in the eval function, when you're asked to enter the elements, there are two ways you could enter the elements. One, as shown on the screen here. You enter all your elements and put a comma. Automatically, it will be treated as a tuple. Or you start your parenthesis, you enter your values separated by a comma, and you close the round brackets or the round parenthesis. Is that clear? So both. So here in a list, square bracket was a must when you're using the eval function. But here, round bracket is not a must. You can just put commas and separate the elements as well. Okay. Now, let's compare this strings with lists. Now, what happens with string with list? Everything that you have learned with strings and list and what we're going to learn with tuples are almost the same. So similarity with strings and lists means all the things that you see here are exactly similar to what you do in a list. Coming to the length of a tuple. Length of the tuple talks about the number of elements in the tuple. So here in a string, it talks about the number of characters in the tuple. In a list, it talks about the number of elements. So length is going to remain the same. Only thing that I would want you to note here is this. This tuple looks like it has 4 elements. No, but it has only 3 elements. The first element is 101. The second element is puja. And the third element is a pair of elements, which is 35 and 46. So the length is going to be, because that's a nested tuple there. So the length is going to be 3. Then we know the plus operator works as concatenation. So you see the result here. Then we know the asterisk sign works as a repetition or replication. So can you see this string repeated 2 times in a tuple? Then we know the in operator is a membership operator. You have in as well as not in. What does it do? 3 in 1, 2, 3 means it's checking if 3 is a part of the tuple, which is 1, 2, 3. In this scenario, it is, so it gives you true. Suppose you had written 5 in 1, 2, 3, it would have given you false. So I'm going quite fast with this because this we have learned with strings. And the same thing again, we are learning, we learned again with lists, and now we are learning with tuples. Is that clear? Okay. Let me take you to my next screen now. Some more similarities. Indexing. In a string, we had forward and backward indexing. In a list, we have forward and backward indexing. Same thing is applicable here also. So if you look at the example, it'll be very easy for you. When you say tup1 of index value 1, that's 88, and tup1 minus 1 is the backward indexing, you get 56. Then slicing also works the same way like the strings and the list. And similarly is the traversing. Okay, but in the traversing here, I would tell you in this second method that we have written here, if I write print x, it would not display the values for me. It would display, because x is a range here. What is the difference here? X gets each value of the tuple. So it displays 10, 20, 30, 40 as you see here. But here X is a range which is referring to the index. So here X's value would be 0, 1, 2, 3. How many elements do you have? 1, 2, 3, 4. So 0, 1, 2, 3. If you really wanted to display the value, then we had to write tup1. Okay, so it would be print tup1 in square bracket X. And not just X, because when we use X with the range option, it is not going to be displaying the value. In fact, it's going to display that index number that we're talking about. Clear? Okay. Apart from this, even comparison operators that we did with strings and list is also going to be working with tuples. When can you say 2 elements, 2 tuples are equal? If the elements at the corresponding index locations are the same. That means element at index location 1 of the first tuple, if it matches with the element of index location 1 of the second tuple, then we say it's the same for all the elements, okay? So the comparison operators can also be used with tuples, okay? So let's go ahead and slightly see the difference between a tuple and a list. First thing you have to remember, that list is mutable. You can go to a list, make changes to the existing list. Tuples are immutable. Secondly, list is implemented using a square bracket. Tuples are implemented using a round bracket. And some more differences we will see here. In this example, if these were all tuples, all the things that we do is possible. Okay, so just pay attention to what I do here. I have a tuple called with values apple, banana, and cherry with index numbers what? 0, 1, and 2. Now I'm saying this tuple 3, that means I'm creating a new index location. I'm trying to put orange. If it was a list, this is valid. But for a tuple, since after creation of a tuple, you can't do any modification in that tuple, you get an error. So you can't add an item after you have created a tuple. Then similarly, suppose this is index number 0, 1, and 2. If it was a list, it meant to change this to 100. Okay, but because it's a tuple, this is not possible. So again, you get an error because updation is not possible with a tuple. Now, if you have a tuple and you want to delete some particular element from the tuple, in a list, you remember we made use of the remove or the pop methods. Okay, in a tuple, you can't do so. Okay, because again, you're trying to modify the tuple, which is not allowed for immutable data types. But if you want, you can delete the complete tuple. That is by writing del and the name of the tuple. That is possible, deleting the entire tuple. But the created tuple, if you're going to try making changes to the created tuple like you did with a list, it is not going to be possible. Is that clear? Okay. Let's go ahead. Now, packing and unpacking tuples. Packing, you've just seen few slides back, but you did not realize that it was called packing. When you give value to a tuple, that's called packing because you're packing different data types into or similar data types into a tuple. For example, if I write A is equal to NIT 5000 engineering, 3 values, I'm packing it into a tuple named as A. Unpacking is the opposite. You're getting the data from the tuple and you're storing it into certain variables. To understand that, I've got 3 variables here: college, score, and type college is equal to A. So what happens? A consists of NIT 5000 and engineering. College gets NIT, score gets 5000, and type underscore college gets engineering. So this is called unpacking, getting data from the tuple and putting it into different variables. Okay, one important thing that you need to remember here is the number of variables that you write to the left side of this last line should be matching with the number of elements that you have in the tuple. Otherwise, it could cause an error. So if here I wrote only college and score and wrote equals to A, it would result in an error. But I would want to show you something different that's not in your syllabus, but I would want to show you something different. Suppose I have a tuple. Okay, I have a tuple as I've shown here. And now I've written only 3 variables: fruit 1, fruit 2, fruit 3. Then does it cause an error? No, because of the asterisk sign that you put here. Now what exactly happens? Fruit 1 can take the first variable or the first string, which is apple. Fruit 2 gets the second element from the tuple, which is banana. And because you said star fruit 3, it only means fruit 3 not just stores one value, can store many values. So when I say print fruit 3, what does it show me? Cherry, mango, and pear. Okay, but it shows it to me as a list. So fruit 1 data type is going to be a string because it's just apple. Fruit 2's data type is going to be a string because it's banana, but fruit 3's data type is going to be a list because it has a list of strings, which is cherry, mango, and pear. Okay, so this is what you will see as your output. Okay, but what if the asterisk sign was somewhere with the first variable or the second variable? I'll show you another example. So here you have asterisk sign with the second variable. Then what happens? Fruit 1 takes the first one, fruit 3 takes the last one, and whatever is left in between is taken by fruit 2. Just to see, I've given a print command here. Yes, it will display banana, cherry, and mango as the element of fruit 2. So putting the asterisk sign before a variable means it can store multiple values, but it stores it as a list. Is that clear? Syllabus wise, you would not see it in your books or anything like that, but I thought it's good that you know about it also, because this logic could be helpful somewhere else. Is that clear? Okay, let's just get ahead. What? Now I told you tuples are immutable. You can't change the value. But what if you want to change the value? Then, you have to do some, going around the bush kind of a concept. Or, doing it in the wrong way, okay? Not the straight way. What probably you could do is take the tuple, convert it to a list, do the modification, and convert the list back to a tuple. And how are we doing this? Making use of the functions called list and tuple. So here in this example, if you see, I have a tuple called x. List x, what does it do? It takes the tuple, converts it to a list. So now y is a list. And then you're saying y of 1 is equal to kiwi, which means I'm replacing banana with kiwi, but that's in the list. Then what did I do? I took the list and I converted into a tuple and stored it back into x. Now that doesn't mean, now x has got a new value, but that doesn't mean the memory location where apple, banana, and cherry were stored, they get manipulated to apple, kiwi, and cherry. No. Another memory location gets created because the value, you cannot go and change in that memory location, right? If it's immutable, but it looks like x has changed. Yes, I agreed, x has changed. But what is happening is x has changed because x is no more referring to apple, banana, cherry. It's referring to apple, kiwi, cherry. And we tried to do this manipulation by making use of a list because we know list is mutable, so I can make changes. Okay? Okay, so now the last thing that you would want to know is in this chapter is all the methods and functions of a tuple. Now this is also going to go very fast is because all the methods that we are going to learn here are already methods that you have learned with list. So it goes quite fast. First, coming to count function. What was the count function doing? You've written an item there. It finds out how many times this item appears in the list and gives you that number. For example, I've written here count P. So in A, P, P, L, E, which is stored in a tuple, how many times does P appear? P appears 2 times. Suppose you said how many times does X appear? It would give you 0. Okay. Coming to the second function, it's called the index function. What does the index function do? It returns the index number, forward indexing, okay? It returns the index number of the element that you have specified. But if you specify an element that does not exist, then it gives you an error. So you wrote index L. So index of L is nothing but 0, 1, 2, 3. So it gives me 3. Suppose L appeared multiple times. It gives you the index number of the first occurrence of L. Okay. Now, coming to a function called len, we already know. It tells you the number of elements in the, in the tuple. Now, just note the way len was used. Okay. I would just want to do some annotations here. Just note the way len was used and the way index and count was used. For index and count, you wrote the name of the tuple, dot, and the name of the method. For len, you just wrote len and in bracket the tuple. Okay, that's why len is called a built-in function. It's a function, whereas index and count are called methods of a class called tuple. And whenever we've learned in string as well as list, whenever we call method of a class, we use the name of the list variable, the string variable, or the tuple variable in this scenario, dot the method name. But whenever we use the functions, we just wrote len or the function name, and in bracket, we specified the string or the list or the tuple. Clear? Okay. Coming to the max function, what does the max function do? It looks across or looks through all the elements of the tuple and tells you what is the largest value. So in this scenario, the largest value is nothing but 700. Okay. Similar to your max function, we have the min function. Now, what does the min function do? Obviously returns the lowest value. Oh, I have done a mistake here. I would not want to correct it. It's not 700. It's 200. I think I just copied it from the previous slide and forgot to change. Okay, so min is going to give you the lowest value. Now, what would sum do? Sum would give you the total value. That means add up 450 plus 700 plus 200. And in this scenario, it gives me 1350. Okay. Then you had learned a sort function or a method of the class list. Okay, you had written the name of the list dot sort, and it was arranging for you in ascending or descending order. There is a function here called sorted. But remember, the function is not going to change your tuple. What does because you can't rearrange a tuple, it's immutable. So what does the sorted function do? It takes the value of your tuple, all the elements of your tuple, converts it to a list, arranges in ascending or descending order depending upon what you're specifying, and then displays or gives it to you as a list. So your original tuple remains unchanged. To understand this, can you see a tuple here, T? Now I said sorted T. So it picks up 1, 3, 4, 2 from T, converts it to a list, arranges it in sorted form, and stores it in Z. So what is Z? Not a tuple, but a list. So when I said print Z, can you see a list? How do you know it's a list? It's the square brackets. It's sorted. And when I said print T did not change. It remained the same. It can't, right? Because it's immutable. Okay. This was ascending order. If you wanted to sort it in descending order, what would you do is use this syntax. You write the tuple. In this scenario, the tuple would be T, comma, reverse is equal to true. You remember writing reverse is equal to true in the sort method of the list class also? Same concept here. But remember there I was using the method of a class called list. Here, sorted is not a method of a class called tuple. It's just a built-in function that is helping me do this. But remember, the answer was never as a, as a tuple, because tuples are immutable. Is that clear? So this chapter went fast is because it's quite similar to your, I didn't have to explain traversing means what or slicing means what, because we've already done strings and lists. And I would suggest that when you study computer science, you can't just go to a topic and start learning it. Our chapters are all connected. Unlike your, maths or other subjects, where you just, I wish to do chapter 10, so I do chapter 10 and then I come to chapter 1. No, for us, the order is a must, because as we move ahead in the new chapter, we are taking forward some knowledge that we learned from the previous one. Is that clear? Okay, in the next video, I'll be showing you few examples. Okay, not much, because all the questions that we did with a list can be done with a tuple, provided you were not modifying the list. So all the questions which were only looking at the list elements and trying to do some calculations, all those questions we could do using tuples also. Is that clear? So I hope things are clear. Though I went faster, I'm assuming you're with me through these chapters, so it's easy for you to understand. Okay, thank you.